Now let's look at this figure 17-13 from Stallcup's Electrical Design Book of Volume 2. And basically we're using 490.21 and 490.22 where we would select the components that we would use for overcurrent protection for conductors and equipment. Now, we know from our experience now in the 2020 NEC that if we're using medium voltage equipment, we refer to Article 311. If we're picking up the ampacity of conductors based upon conductors in conduit and free air or in the ground, or cables in the same manner in some cases, then we also go to Article 311. But when we select components and equipment like switchgear, switchboard, panel boards, and the overcurrent protection means that we select in 490.21, and 490.22 is used also. You know, we have a window, that kind of thing. But notice when we are using fuses as the overcurrent protection for the conductors on the load side to the equipment or service or whatever it may be, notice at the left-hand top side of the illustration, non-automatic, all switch cutout, or air load interrupter switch shall be permitted with fuses. But additional information is required. Fuses shall have suitable current carrying capacity, carry the amount of current to supply the load, clear on short circuits and ground faults, and have a suitable interrupting rating. In other words, they should interrupt the amount of short circuit current that the utility transformer, for example, could deliver to the line side of these fuses. And then further, these devices shall be permitted to serve as the overcurrent protection plus the disconnecting means when properly installed in the proper equipment. The interrupting rating of this switch shall equal or exceed the continuous current rating of the fuse. So the fuse is sized at 125%, and if you derate the fuse 80%, then you have accomplished the same task as taking 80% of the fuse. For example, if it's a 100 amp fuse, you take 80%, that's 80 amps. If the load is 80 amps, then multiply 80 by 125%, and that's be 100 amp fuses. Same way for the circuit breakers below. And then notice they're telling you that the service equipment could be installed in a vault or consisting of metal enclosed switchgear. Now, dropping down to the circuit breakers, this would be 490.21a. The fuses above was 490.21b that listed all the arrangements. Now, automatic trip circuit breaker, suitable current carrying capacity and interrupting capacity, just like the fuse. The circuit breaker must have enough interrupting capacity to interrupt the amount of short circuit current that the utility transformer could deliver to the line side of it, just like the fuses above. And again, the equipment, just like above, could be installed in a vault, metal enclosed switchgear, switchboard, any of those enclosures that you find in Article 490. And then the very same thing, the circuit breaker shall be permitted to serve as the overcurrent protection for the conductors and the equipment, and also serve as the disconnecting means. And that's what our figure 17-13A here is illustrating.